In our last video, we built the foundation for form handling in Flutter. We learned about text form field widget, form widget, and how global key connects everything together. If you haven't watched that video, I will drop a link in the card above. It's essential for understanding today's tutorial. Now, here is where things get really exciting. We have our form widget set up, but right now it accepts anything. Empty fields, invalid email, invalid password. And that's a security nightmare waiting to happen. Today, we are going to fix that. We will learn how to validate our login form properly along with some best practices. So by the end of this video, you will know exactly how to build forms that validate user input. So let's dive in. Alright, let's quickly look at where we left off in the last video. We have our login form ready with two text form fields wrapped in a form widget, and we have our global key connecting everything. And on the button press, we are calling the validate method, but we haven't defined any validation rules yet, and that's what we are about to fix. Perfect. Now we are ready to add the actual validation logic, and it's surprisingly simple. Here is the magic property that makes text form field so powerful: validator function. So what is this validator function? Let me break it down for you. The validator is a function that receives current value of the field as a parameter, checks if that value is according to our rule or not, returns error message if something is wrong, returns null if everything is okay. Let's implement our email validation. First, let's add a if condition to check if the value is null or empty. And if it is, then we return an error message. Please enter your email. Next, let's add another if condition to check if the value contains @ symbol. Value.contains @ symbol. And if there is no @ symbol, we return an error message. Please enter a valid email. And if everything is good, we return null. Hit save. And now if I hit the login button with an empty email field, we get an error message. Please enter your email. Let's try entering an invalid email address. Hit login again. We see a different error message. Please enter a valid email. See how clean that is. You define your rules and return error messages when rules are broken, and return null when everything is fine. Flutter handles the rest, displaying errors, styling them, and positioning them. You just focus on the business logic. Now let's add validation to our password field. First, let's check if the password is null or empty. And if it is, then we return an error message. Please enter your password. Next, let's add another if condition to check the length of the password. And if it is less than 6, then we return an error message. Password must be at least 6 characters. And if everything is good, we return null. Hit save. Notice how we are using the exact same pattern. Check the condition, return error messages. And if everything is valid, return null. This consistency makes your code more readable and maintainable. And now if I hit the login button with both fields empty, we get error messages. Please enter your email. Please enter your password. Let's try entering an invalid email and password less than 6 characters. And if I hit the login button, we see different error messages. Please enter a valid email. Password must be at least 6 characters. Finally, let's try entering a valid email and password greater than 6 characters. Hit the login again, and this time, no errors. How cool is that? Flutter is handling all the validation UI for us. We just define the rules. Now, here is an important question. When does this validation actually run? And the answer is validation happens when you explicitly call validate method on the form state object. Here is the flow. First, user clicks login button. Next, the onPress event is triggered. Next, The validate method is called on the form state object. Next, form widget loops through all text form fields. Next, each validator function is then executed. Next, errors are displayed if any validator returns a string. Next, validate method returns true if all validators returns null, false otherwise. This approach is called as validation on submit, where users can fill out the form at their own pace and only when they hit the login button they get the feedback. This is a much more user-friendly approach. Now that you understand the basics, let me share some best practices. First, instead of writing these validators inline, extract them into a separate class. This makes your code more reusable and testable. Here is the refactored version. I have created a separate validation helper class called form validators under utils folder. Notice I have also improved the email validation using a regex pattern. This checks for proper email format instead of just looking for an @ symbol. And now you can use these validators anywhere in your app like this. This is so much cleaner. All your validation logic is in one place. Easy to maintain, easy to test, and reusable across your entire application. You could just use this form validators class in your login screen, registration form, profile edit screen, anywhere you need validation. Second, provide clear, helpful error messages. Your error messages should be clear and specific, actionable and not technical jargon. Good error messages tell users exactly what's wrong and how to fix it. Bad error messages just frustrate users. Third, handle form submission properly. When your form is valid, you usually want to do something with that data. Maybe send it to an API, save it to a database, or navigate to the other screen. The flow is first validate your form, and if the form is valid, then process your data and respond accordingly. Now let's take it one step further and add a loading state. This is important for production apps because API calls take time and users should see that something is happening. First, let's create a Boolean variable called isLoading and set it to false by default. Means we are not loading. When we start processing the form, we will set it to true, and when we are done, we will set it back to false. Now let's update our submit function to use this loading state. Let me break down what's happening here step by step. First, notice that our function is now async and returns future void. This is necessary because we are performing asynchronous operations. Operations that take time and don't complete immediately, like network request. When the form is valid, the first thing that we do is set isLoading to true using setState. Then we have a try catch finally block. The try block is where we put our actual work in real app. I'm using future.delayed to simulate an API call that takes 2 seconds. And the await keyword makes the code wait for this operation to complete before moving on. If the operation succeeds, we handle the success case. And if it throws an error, then catch blocks handle the error case. Here is the really important part, the finally block. This block always executes, whether the try block succeeded or failed. This is a perfect place to set isLoading back to false. This guarantees that even if something goes wrong, we will reset the loading state and the user won't be stuck with a spinning loading indicator forever. Now let's look at how we use this loading state in our UI. There are two key things happening with this button. First, the onPress property. Here we are using ternary operator that says if we are loading, set it to null, which will disable the button. Otherwise, use the submit form function. This is crucial because we don't want users clicking the button multiple times while we are already processing a request. Second, the child property. Here also we are using the ternary operator that says if we are loading, then show a circular progress indicator. And if we are not loading, then show a normal login text. Now let's fill out the form. And hit login. But the circular progress indicator is not clearly visible. So let's fix that by removing this white color. Hit save. And now let's try again. And now if I hit the login button again, the circular progress indicator is now clearly visible and the button gets disabled for 2 seconds, preventing accidental double clicks. After 2 seconds, the loading indicator disappears and the button returns to normal state. This gives user a clear feedback about what's happening. This is a professional touch that makes our app feel polished and responsive. And that's it. In the next video, we are going to see some tips and tricks which will improve our login form further. I hope you found this video helpful. Hit like and subscribe for more awesome Flutter content. Until next time, keep coding, keep learning, and I will see you in the next video. Happy coding!